Okay, Brett, are you okay if we start?
Yep, whenever you're ready.
Okay, great. So good evening, everyone, and thank you for joining the 20th webinar in Oral Medicine for 2018, hosted by the Perth Oral Medicine and Dental Sleep Centre. My name is Amanda Punyuan, and I am a final year Oral Medicine Registrar at the University of Western Australia. So to all of our viewers this evening, and from those around Australia, thank you very much for tuning in today. A very warm welcome. I am really looking forward to a fantastic presentation by Mr. Brett Chalklin. So this presentation has very kindly been sponsored by Julie and Aaron from Cohesive Finance. They have a lot of experience in providing financial solutions for business and personal needs. So if you have any financial problems, please show them some love. So this year there have been 22, or there will have been 22 webinars by the end of this year. This is the 20th webinar, and there are 2 more left. Now, this is a way for the Perth Oral Medicine and Dental Sleep Centre to thank their referrers for their ongoing support, and also to provide an education resource. There are 2 more to come. Each CPD is worth 1 hour, and the certificates will be emailed to you after this. If you have any questions during the Brett's presentation, please feel free to type the questions into the left-hand side in the little text box there, and we'll look at questions at the end as well. We do also have a Facebook page called Tongue in Cheek, where we discuss oral medicine cases, and people are free to post cases if they have their patient's permission. So please feel free to join it if you're not already on. So Brett Chalklin. So Brett is part owner and manager of the Digident Lab. He has about 24 years experience working as a dental technician in Perth's private and public sectors. He has an interest in the ongoing digital developments that shape the dental industry, and he endeavors to incorporate these new workflows into the daily production at the Digident Laboratory. So what this bio doesn't tell you is that Brett is actually a really nice guy, and his splints are fantastic. I use them myself, and I do really like them. So over to you, Brett.
Okay, great. Thanks once again, Amanda.
Brett, you might have to turn your microphone up a bit.
Okay, just a moment. Can you hear me okay? That's at maximum now. So yeah, thanks Amanda. Thanks for your introduction. My presentation this evening is titled Splint Decisions on CAD/CAM and 1,000 Reasons to Change. And this is a bit of a play on words for us because it was a big decision to choose to change our workflow and going down a CAD/CAM path, especially to make splints, was something that isn't sort of largely done. So it was a big decision that we had to make. And my 1,000 Reasons to Change comes in the form of our first 12 months saw us put it through a little over 1,000 splints in that time period, which is pretty good for a small lab. I'd firstly like to declare a few conflicts of interest potentially. Digident Laboratory, as Amanda mentioned, is co-owned by myself. I work fairly closely with the specialists at the Perth Oral Medicine and Dental Sleep Centre, and in fact the lab is located at the Jandakot Clinic. And some of the software that I'll be showing in this presentation has been developed by myself and the laboratory, and it's going to be potentially commercially available in the near future. I'd like to firstly just lay some foundations and talk about digital technology in the dental workflow. I think when people talk digital technology, immediately what comes to mind is intraoral scanning and CAD/CAM, and that's both in the clinic and the lab. You know, there's plenty of options available clinically with CAD/CAM as there is with the lab, but also now we've got 3D printing, and there's also the use of digital imaging clinically as well. But I think what gets overlooked quite so often is the use of email, the use of clinic and lab management software, and the use of digital photography. And as Amanda mentioned, I've been in the industry for about 24 years, and emailing and managing our lab work with software and digital photography weren't things that were available when I first started out. So they definitely form one of the day-to-day elements of our workflow, and they're fairly crucial to making sure that things go the way we want them to. So to me personally, digital technology doesn't come in the form of all the high-end expensive stuff. It's all the little things also that knit together the workflow that we use on a day-to-day basis. I'd also like to touch on why we sort of considered changing. We're a fairly new lab, and as our demand increases, we needed to explore our options in coping with that demand. And putting my feelers out there, there was a fairly limited pool of skilled technicians out there here in Perth. We're a long way from the rest of the country. And I haven't objected to maintain a level of quality that I see for myself, and I want that to be a standard that I put out in all work that leaves the lab. But also I want to keep current with new techniques and developments in what it is we do. This is a career that I've chosen, and I wish to stay current within that. So as I mentioned, my options in doing this were to hire some new staff, and there's pros and cons with that. You know, I potentially could have found the diamond amongst all the stones and found the perfect person that was up to the standards that I was wanting for myself. The downside of hiring somebody new means that there's potentially time to train them. There's obviously personalities that sometimes come into play when you're working in a pretty close environment with somebody. And our other option was to look down the path of investing in CAD/CAM. And once again, there's a lot of pros and cons with doing that sort of stuff as well. CAD/CAM comes at an expense, and it's a pretty big expense, so you want to make sure that you're making the right decisions. So I kept the feelers out there looking for new staff, and in the meantime I also did an awful lot of research in looking into CAD/CAM options as well. So at this crossroads I spent months, in fact, looking at different CAD/CAM options, milling technology, printing technology, and how I can apply that to my splint manufacturing. I spoke to a lot of sales reps, and they're very good at wanting to make a sale. So I decided to take it a step further, and I actually got in touch with other laboratories that were using different CAD/CAM equipment, and I saw what it was like on ground level for them, and I figured out all their problems, all their victories, and all the little idiosyncrasies that comes with each of the different systems that were on offer. And I can tell you there's things with everything that you need to weigh up and consider as well. So I went to the extreme of even flying to Sydney to see another lab that was producing splints using a particular system as well. I sent my own models off to other labs to get digital splints made and stuff like this as well. So I did an awful lot of research because I figured it was a big choice that I was making, and I wanted to make sure I was making the right choice, and I absolutely recommend anybody that is going down the path of looking into anything CAD/CAM, don't necessarily go by what you see on videos on YouTube or what salespeople are wanting to sell you. Find people that use the actual equipment and get their experiences, get their input and advice on potentially helping you out. So based on all this research, I made a choice, and I went with the Gerbach DNA generation machinery. In the middle here on the right you can see the Motion 2 mill, and in the middle on the left is the MAP 400 scanner. One of the things that attracted me to this system is it's a complete workflow system, and it integrates all the elements for CAD/CAM manufacturing. Now, anyone that knows anything about CAD/CAM, there's an awful lot of software that's attached to it. In fact, you've got your design software, you've got your scanning software, and those two softwares need to talk to each other. Then you've got your nesting software, and you've got your CAM software, which controls your milling strategies. All of these softwares need to talk to each other, and a lot of the systems I saw in play in different labs have different elements of different pieces of equipment, and potentially in some cases 3 or 4 different softwares that all need to communicate, and when there's a lack of communication the whole system stops. So the Gerbach system has all of the software included in one package, and it all talks to each other. It's very intuitive and seamless, and it's very simple to use from a user perspective, which was very attractive to me. And this is a little snapshot of our CAD-CAM corner in our lab here. We've got a couple of the Motion 2 5-axis wet and dry milling machines, as you can see, and the MAP 400 lab scanner. And we use the Ceremal Mind software, which is the Gerbach version of ExoCAD design software. One of the things that attracted me to this as well is it's what's considered an open system, so it can receive and output STL files and use those STL files for all design work that needs to be done, which is very good. We don't pay a license fee to use all of our equipment. We pay for support, and support was another key factor, and this is one of the things that was reiterated by a lot of other labs. We're not experts when we first buy this stuff. We need help, and I can stand by the help that we get very, very strongly. It's second to none, I believe. Our support office is in Singapore, and they are on the same time zone as us here in Perth, so it makes it very, very simple. We're not waiting for people overseas to wake up or go to bed or whatever, and they are there for us when we need us. And the same with the supplier that I deal with here in Australia, Tommy. He's been absolutely awesome, and I recommend him to anybody for advice, for information or input on anything that they're looking for CAD-CAM. One of the things that also attracted me was the capabilities of this system. If you look in the bottom right where it says acrylics, the second listing is the Splint, Ceremal Splint. So our system has the Splint module, and the Splint material is a material that Gerbach developed. And as you can see, there's an awful lot of different possibilities with this system. Being a 5-axis system, it means we can mill undercuts, which is essential for milling splints. And having a wet strategy is also imperative to mill acrylics. But having those capabilities means we can do an awful lot more, which is very important for us to make sure that we were future-proofing our system and having the right system in the lab that can potentially open the doors, which it has, to other possibilities. And I'd just like to point out as well, the Gerbach system, it says in the middle of this circle, it's all in-house. Now, they're one of the few companies that make mills themselves. They develop their own version of the ExoCAD software, so they come up with the strategies for the milling of all the different materials. And you can see a lot of the materials listed in this wheel start with the word Ceremal, and that's all materials that they develop as well in-house. So they develop the milling strategies to mill these materials, which makes it very seamless and very accurate as well. So we never have a problem with any of the materials that we get and the strategies that are in the system to mill them. Everything we find works very, very well. So that's a bit of background, and the next section is going to go through the design process of a CAD-CAM splint using our system. It's going to be very pictorial because it's probably the easiest way to describe it. So for us in particular, this is where, for me, it all starts in the clinic. The jobs are ordered mainly, the jobs that come to Digident mainly come through the Digident Laboratory app, which our clients, most of our clients use. And I'll just quickly show you a short video of how simple it is to order a job. Essentially, this is a live job order being done. A dentist literally selects the patient from the patients that have been assigned to them. They select their correct location, and go through the job order form and select all the details as required. Put in a couple of pieces of information. And some notes should they require it in the same fashion you would on a lab sheet. But the addition that we've got within our app, we can add photos or files to the job form, which keeps it all in one place and it's there for records. You can see a photo has been uploaded to the job form. So when I get a notification that that job is ready for pickup, all the information, as you can see, that's the lab sheet, and as it scrolls down you'll see it will say print label. So that label will get printed, that barcode will be a part of that job form, and it can be tracked within the system throughout the whole process of the app system that we've got. And you can see here the left side is the job order, the right side is the finished lab sheet essentially. And like I said, it's the little things that make the bigger picture for my money. It's being able to communicate with the clients, it's being able to put all the relevant information for each case in one place, and that's what we've tried to do. I personally looked for different management software systems, and they didn't tick all of the boxes, so we took the risk and essentially started to develop our own. And what you see here is not the prettiest, but it's a working beta version of our software that is still in process of being developed. Yeah, it's got a lot more features than what you can see here, but that's not what we're here to talk about. So once I've received that notification, I arrange for that job to be picked up. And most of our cases I receive impressions for. Our system is capable of using intraoral scans, which is fine, but my recommendation for me personally, it's not what I sort of say is gospel, absolutely not. For me to use intraoral scans and go completely modelless, I run the risk of not being able to have the luxury of refitting that finished splint to a model. If I want to then make 3D printed models without printing equipment myself, I need to outsource that, and that's cost I have to then pass on. So to try and keep costs at a minimum for something as fundamental as a splint, I personally think impressions are still the way to go for the time being, and utilising a PBS material means that things don't distort with time or in transit and all the rest of it. So those impressions have been poured up and articulated as we normally would, and then we're ready to start the scanning and design process. What we've got here is essentially the home screen of the Cerebral Mind, which is the whole design software, and it's segmented into three parts. As you can see, we've got running from left to right, the project, the job definition and the actions. The project means we essentially put in the details of the case, the client, the patient's name, who's doing the case and any other notes that we want to keep. We then define the case depending upon what it is we're making, and you can see that most of the actions are ghost images at the moment because we've got no information in there. It's only when we input some of that information that we've got more options available to us in the system. So I've gone through and added some information here. You can see in the job definition, the upper arch is highlighted blue, and that's designated as being a bite splint, and lower arch is purple, and that's an antagonist. And once we've gone through and saved all that, we can then go through and start with our actions. And the first on that list is the Cerebral Map. The map software is the scanning software. The Mind software is the design. The match is the nesting, which is essentially taking the construction and positioning it into a virtual huck or blank or block, whatever it may be. And the cerebral motion is the CAM, or the milling software. So if I was to click on any of those teeth, it gives me this option where I can go through and select what that restoration is going to be. In the middle, it gives a list of materials. You can see here it's only got Splintec because on the left side towards the bottom it's highlighted bite splint with a blue tick. and the milling strategies will then change according to what material. And the milling strategies will then change according to what material we are then selecting for our construction. And the milling strategies will then change according to what material we are then selecting for our construction. Once we've decided on what it is we're making, our next option is to obviously scan through the models, and that's pretty basic. We position the models in the scanner and it gives us a nice pretty scan of what we've got, always starting with the upper, then the lower. I'll always go through and trim the models. I'll basically only keep the necessary information. So the base of the model I'll cut away, and by doing that it essentially just reduces the size of the data file that will then be stored in the computer, which basically means less data weight in the whole system, so more cases potentially before things need to be put into an external drive. The next option, once we've scanned our upper and lower models, is to add them into the fixator. Now that's essentially an articulated model scan, and what you can see is the models here are positioned in the fixator, which is a transfer stand that will go into the scanner, and the fixator is calibrated with the same calibration tool that's used to calibrate the Artex articulator. So the orientation of the base plates and the opening and height are all exactly the same between the Artex and the fixator, which means when we put those models into the scanner and then we use the virtual articulator, it's recognised as being in the exact same position as we articulated them. I think it's also worth pointing out that when we use an articulator, whether it's in CAD/CAM, whether it's physically, a lot of the time we don't get face bows to position things. So we are using averages, we are positioning things where we think they would be. Slight discrepancies in that position compared to the patient will obviously mean that there's a slight discrepancy in how that jaw will open or close, depending upon what it is we're making. So sometimes there is always that need to have adjustments in the clinic, unless we're getting face bow bites, which can be time consuming. I actually attended a course fairly recently, actually earlier this year, where we were doing some fairly complicated full arch construction stuff, and the lecturer went through and took a centric bite using a face bow, a lateral left, a lateral right bite, and a protrusive bite, and I sat there with my timer, and from start to finish it took him 50 minutes to do the bites. But this is working on sort of high-end sort of full arch reconstructions. So he said to me when I quizzed him about splints, he said it's up to your clinicians as to whether or not they take face bow bites, which will take a long time. We'll spend 10 or 15 minutes spot grinding and balancing occlusion in the chair. Once we've scanned that in, as you can see here, that's the vestibular scan. The vestibular scan is always much quicker than the upper and lower scans. The antagonist model is always a quick scan. There's no real detail that's required. We can always add scans to fill in black spots if the initial scan misses. We can sort of orient the models to point the camera in a particular area to try and fill in that area if it's sort of missed a little bit. And you can see from this picture there's the purple scan is that vestibular scan, and the grey blend in the models is the initial upper and lower jaw scans. Once we've got those three components, the computer will try and automatically match where that upper individual scan and lower individual scan sit within that vestibular scan. So we can then use that for our process of construction and design. If those models are slightly off, we do have a feature where we can actually manually try and reposition them. But these are the final upper and lower trim scans in their articulated position. So once that's done, it will give us the next option, which is to start designing. Now, designing the bottom, the bite splint bottom. This is, in my opinion, probably the most crucial stage. And speaking to many people about the whole process, I think this is the one that most people understand the least in terms of how to tweak the parameters to suit what we're trying to do. You can see, obviously, the undercuts in this case are highlighted in a darker brown. We've got the arrow in green in the middle, and that arrow is essentially designating our path of insertion and our undercuts at that path of insertion position. The wizard gives us our prompts and our features in each different page. You can see here next to the wizard it says design bite splint bottom. These three top properties, block out undercuts, the offset, the angle and the allowable undercuts, they essentially I think are the three most crucial parameters that need to be understood and worked with in order to make a splint fit. When we're making things manually, we can determine a desirable and an undesirable undercut. If it's undesirable, we block it out. If it's desirable, we utilise it. Now, the computer system, you can see here where it says allow undercuts to, as the third listing there, and I've put 0.025 millimetres. Anywhere there is an undercut, whether it's deep, whether it's shallow, it will only engage what we designate in that position. The angle is the blockout angle beyond that 0.025 millimetre allowance. So once it's engaged that 0.025 millimetres of undercut, it will block out at 1 degree past the zero. So it's slightly greater than parallel. And the offset here is 0.05, and it's an ever so slight sort of space over the construction. I've got a slide a bit later on where it sort of shows these things. The bite splint bottom properties, the smoothing is at 17%, and this smoothing feature essentially smooths out the contour between the teeth at the interproximal margins. And if you've got greatly contoured teeth or interdental spaces or even missing teeth, you obviously want this smoothing feature or percentage to be a fairly high number. I personally don't really go beyond 5 or 6% even in severe cases. Otherwise, when there's fairly low contour between the teeth, you can reduce that down to 1 or 2%, and it will essentially engage the contour of the teeth to help with retention. And your minimum thickness is essentially the minimum allowable thickness of the finished acrylic. So once we've set up those parameters, it will then lay this white layer over the model, which will then fade out. And you can see how, based on that path of insertion, it's blocked out, especially if you look towards the 7 there, distal of the 7, you can see how that blockout line runs parallel with the path of insertion line. If you look at the anteriors, you can see that it sort of follows a little bit of contour. It's a little bit hard to see how it's going to sort of engage the undercut areas at this point, but you can see how at 2% it smooths out a little bit between the interproximal areas of the teeth as well. So fairly shallow undercuts in this case, so I'm going to try and engage the tooth contour to help with retention. And this is what I was talking about before. If you look towards the cursor in the middle of the screen at the 7, you can see how at the incisal it sort of rolls down and engages a little bit, and then we have a very parallel line running down where the splint is essentially blocked out at, in this case now, 0 degrees. You can see it's a fairly light shadow space over the teeth, and that's the offset. So essentially that takes away a little bit of the detail of contour on the occlusal surface. So when you have really deep fissures and stuff like that, it's going to smooth those areas out. Once we've designated the bite splint bottom properties, we can move on to the virtual articulator. And as you can see, the models are nicely positioned where I had them on the physical articulator once they've been transferred to the fixator stand. And we can see that's quite nice there. I designate a few little options, change the angle of my incisal table according to how I want things to be done. And once again, if we've got face bow bites, we can input all of this information, all of the things that we can do with a physical articulator, we can adjust and change on the virtual articulator as well, which is a very handy thing. And what we then do is run it through some articulator movements. Now, running it through these articulator movements will save it into the system. You can see here it will go protrusive and then left and right lateral movement. It will take some time to save that movement, but saving those movements means we can utilise those movements later on. If we don't do this now, we can't utilise the movement feature of the articulator at a later point, which once again I'll show you in a later slide.
Sorry, Brett, are you trying to play a video? Oh,
so, sorry, can you speak up a bit, Amanda?
Oh no, sorry, I was asking if you were trying to play a video because the slide on my screen was gone, but no, that's all good, thank you, sorry about that.
Is the video not playing?
No, I don't think so.
Okay. I'll try to play that again. Is it playing there now?
Yes. Thank you.
Okay. So once it's run through those articulator movements, we'll then save that into the system and we can use that later on in the design process. Okay. So the next thing it will give us to do is to start designing the splint, and it's basically a simple plot or outline that we place around the arch. Obviously we need to engage undercuts in a fashion that's going to provide us with retention, and once again it's analysing the model in the same way that we would with manufacturing a handmade splint, and I've been quite fortunate to have many years experience making them by hand, so I know what it is I'm looking for when I see an undercut and how and where I can utilise that. And once again, it takes a bit of time to understand the parameters and how they change and how you need to apply that design and where you can engage to safely make a retentive splint. And once we've gone through and put our plot around the entire arch, it will essentially lay down a sheet of wax. We can then flatten that out and achieve our first points of contact. And start to build up the splint to the design that we want. And in this case we're making a maxillary stabilisation splint, so I want to have even arch contact and I want some disclusion ramps on the anterior segments. So this is where I begin to build up the occlusal scheme. And you can see here we've got a few features. We can add and remove wax, we can smooth and flatten and increase and decrease the strength of the wax that we add and the brush size and type to do that. So I'm not going to bore you with the whole process of doing that. So I've built up the splint to achieve contact. I've got some ramps in place. It's still fairly rough because as you can see at the very top there's a red and blue scale which tells us how heavy the contact is on the arch. It's very much uneven throughout at the moment, but I can use the adapt feature which will then incorporate the articulator movements that I've saved in the virtual articulator, and it will run through and take away essentially all the wax in the space in the way of the movement. And as you can see, it's still quite rough. I've got nice light contact across all teeth in the opposing arch. So what I then do is go through and smooth it off once again. And I'll just quickly show another short video of the finished splint running through the articulator movements. We've got nice balanced movement across the anteriors in protrusive, nice movement, contact with canines and lateral on both sides. Let's go through here. As you can see, that contact is even right the way through. It's not heavy at any point, which is ideally what we want. So got a nicely nice splint there that moves and functions how we're hoping that it will. Okay, so one of the things I have also picked up over time is I think a lot of people take on these CAD/CAM systems and expect the splint design feature or the splint design modules to do it all for them. You basically need to build up a splint. You need to work the movements in. You need to take it away in the same way that you would wax one up. And I find my background in having made these physically, I know exactly what it is I'm looking for in making a CAD/CAM splint, and I try and achieve that as best I can. So it looks as much like a handmade splint as possible. And one more small video here shows the merged components. So once we finish the design and we're ready for the next stage of production, it will do what's called merge the parts. Now we have a lower splint bottom, which is the fitting surface side, and the top part is the bite splint top, and it will essentially knit together based on that plotted outline that we designated. It will knit the bottom and the top parts together to create that three-dimensional object, which we can then save and then take into the next part of the design process, which will take us to, which will essentially take us to the nesting. Now, nesting is essentially positioning the design into a virtual puck. We need to designate a few things based on the size of the construction. If you look on the left side here, it will name the material, so we can actually physically write on it and use it for later use, because as you can see there, I've got a lot of space that's being unused, and it says height there at 16 millimeters. We have a few limits on the size of the pucks that we can use for splints. I find personally 16 mils gives me most of what I need for all splints. But like I said, we've got some dead space here, so my next and best option is to essentially design a second splint and nest the two together and connect where I need to, so that it will be nicely secured during milling. And once I'm happy with the position, it will give me the option to continue, which will then start a calculation of the cutting tool path that the milling machine needs to take in order to cut out the construction. This, what you see in front of you, is the Ceremal Motion software. So this is the next stage again after the design and nesting. And this is the interface that sort of helps us control the milling machines. So once the splint has been calculated, it will then save it to the little folder which is in the top left corner here, and we can select the construction that we want to then mill, and it will give us the option to then transfer it into the machine. And once it's mill, that's what it looks like. I've got a video here of that particular splint milling in our wet mode. It's quite noisy, but it's, to my ears, no noisier than another normal working laboratory. And to mill one splint, we're looking at around about an hour and 20 minutes per job. There are some special cutting tools and different strategies that you can use which will then speed up that process, but personally the 2 mills running and the design time that's required, I find the way it runs at the moment is perfectly fine. Then those splints come straight out of the machine and they're ready to be finished. Next stage is obviously to remove them from the puck and reposition the splint on the model as we normally would a normal processed splint. What we have done here, I've not adjusted this at all, I've only taken off the connectors and smoothed off those areas. As you can see, I haven't made any adjustments to that fitting surface, and as it was this one, I haven't adjusted the fitting surface either. Sometimes there is certain areas that we've found over the time that need minor adjustments, like especially between the laterals and the canines. There seems to be a big dip between the mesial edge of the canine and the distal edge of the lateral, and it will wrap around that canine and sometimes sort of create a bit of an undercut area that will make it difficult to get on and off. So I just routinely zip that out. And that's the splint fitted back on the Artex without any adjustments, and we can see that our pin on the incisal table is open ever so slightly, and that, in my opinion, is perfect because that is basically at that level of contact that we designed into that splint. If I design that splint with 0 contact, that pin would be on the table, but I design it with about 0.05 of a mil contact, and that's about where that pin is sitting at the moment. But I also like to rebalance the occlusion and just make sure I've got all the movements that we would normally have in a splint functional and ready to go for polishing. And we have some polished splints refitted to the model, and everything's back to where it needs to be. So that's basically the entire design process from the CAD/CAM perspective, but I'd also like to think about and talk about some of the things that happen on occasions, and that's managing a crisis. I mean, we all face situations where things don't always go according to plan, and we have a few benefits that I've found over time using this system and using any CAD/CAM system, I would imagine. One of these things, sometimes when I articulate a model, the bite doesn't always look correct. And I'm pretty fastidious about making sure that the bites are right and they look okay, and when they don't look right, I need to get in contact with the clinician and figure something out. So with this system, what I can do is in that articulated position, in an open position as you see here, I can screenshot that image, I can shoot that off in an email and ask the question, does this bite look okay to you? Do you want me to proceed? Where to from here, sort of thing. So the other luxury of us having our app system, I can actually drag and drop that file and put it into a message on the app, or I can apply it to the lab sheet, which will then notify, put it into a message on the app, or I can apply it to the lab sheet, which will then notify our clients that there's a new message or there's a new addition to the lab sheet. And we can decide exactly which way forward, whether or not we need to take a new bite, whether or not we need to figure some other sort of way forward with the splint. Another thing that we see quite a lot is dogs love splints, dogs love dentures, and we quite often, we have a few serial offenders that we see keep coming back to the lab whose pets must find or smell out their splints all the time. One of the things that we can do is essentially remill the splint as per the original design. So if a patient calls the clinic and says, my dog's eaten my splint, what do I do? The clinic can contact us and say, we need that splint remade, and I can remill it without the patient ever having to come back to the clinic. And once it's done, it can just be a straight insert appointment. So we have that benefit of actually utilising the system to remake a splint exactly as it was made first time round. And there is the occasion where splints don't fit. I have to also admit that this system, using such small numbers to engage undercuts, can be quite sensitive at times. But what I can do is add a new model to the system, to an existing case. As you can see here, I've got the model on the right is the first model that I've made that splint on. The model on the left, the yellow one, I've just added blobs of wax in a few different locations to make a point, but I can select some landmarks that are common between the two, and I can merge those two models together, and we can pretty quickly see some discrepancies if there are any between the two models, so we can maybe figure out exactly why something's not fitting as it should, and you can almost immediately see that the 1-1 has a bit added to the incisal edge. The 2-3 on the buccal aspect of that tooth does the 2-4. And then when we shadow it out, you can see clearly where there's differences. I see sometimes with PVS materials, things look fine until you see the second impression. I don't know why, but sometimes occasionally I've seen teeth when I've overlaid them like this, there's about a millimetre, not quite a millimetre, about half a millimetre or so extra length across an entire arch. So I don't know whether an impression's moved at some point, but if we add an extra half a millimetre to the length of the teeth, then we essentially miss the engagement of the undercuts and we have a splint that doesn't fit. But using a tool like this can help us figure out exactly which way forward. Yet again, it might simply be a case of you need to trim here and everything should be fine, or I can make adjustments, or I can then import that new model and then redesign on that new model. So once again, we've got a few scenarios where I think fairly commonly we encounter things that don't fit. We encounter dogs that destroy or kids that destroy splints and dentures and so forth. But also bites that are incorrect, and we've got ways to sort of try and translate and communicate how we go forward with those things. So that sort of wraps up the whole process for me. I'd like to conclude by saying that I think to some extent these days we all utilise digital technology. Like I said, 20 odd years ago, 25 years ago, we weren't emailing or taking photos with our phones to try and figure something out and create a communication link with our clients. And as this technology develops, it changes the way the workflow happens, and I believe that we need to change with it. And interestingly, I've attended some stuff in Singapore in the last couple of years to do with the digital stuff, and it's amazing how I can be sitting there listening to lectures, and I'm sitting next to somebody from Indonesia who comes from and owns a CAD/CAM laboratory. They've got full digital workflows in stuff in countries where you probably wouldn't think that it was quite common, but it is elsewhere as well, and the world's moving forward, and I think, like I said, we need to adapt and move forward with it. I think more often than not we need to blend digital and traditional techniques, and while they're being refined, we also need to make them time and cost efficient for our day-to-day. Like I said before, with the printing of models for a splint, that's potentially an extra cost that I just can't absorb given the expense, and I don't expect people to start paying out phenomenal fees for splints just because they've got a couple of printed models. And to be honest, when I've compared printed models of different systems with a stone model, I still personally believe a stone model is a lot more accurate. But like I said, I'm willing to keep investigating and watch the technology as it grows and develops, and I hope to definitely go down the road of printing stuff myself one day. New techniques take time and understanding to effectively integrate, especially CAD/CAM. It's a pretty steep learning curve, and it's expensive as a learning curve as well. Mistakes cost time, they cost money, and so forth. So my advice is to any technique that you're looking at incorporating, be it digital or even a new material, spend some time to understand it, and potentially, like I said before, go and see people that use it so they can give you some helpful tips and hints. And with the CAD/CAM splints, a real understanding of the parameters is essential for this for success, and it's something that took me a little while to really understand what it was I was adjusting and how it essentially altered what it was I was doing in the final product. And one of the best pieces of advice I got from another lab owner who I spoke to and spent a bit of time with when I was doing some research, he said to me that the machine's only ever as good as the person operating it. He said the machine will do what you tell it and nothing more. So he said if something's gone wrong, it's because you've done something wrong. So you need to figure out what it is you've done wrong to make the machine do what it's supposed to. So that being said, I'd like to say thanks for your time, and I hope it's been a little bit of information that you otherwise wouldn't have known. Yeah, like I said, I'm located here in Jandakot. I'm open to talking to people about CAD/CAM. It's something that I'm very much interested in and hope to watch develop, and like Amanda said in the beginning, incorporate into everything that I do on a day-to-day basis. So yeah, we'll have a look at some questions.
Okay, great. Thank you for that, Brett. That was very interesting. So we do have a couple of questions. I can see some people typing. And we've got our question here. I find it valuable to provide my technician with a central record at the desired vertical. Does this virtual articulator eliminate the need for this, especially if we provide a protrusive record to indicate the articular eminence angle?
My honest belief and opinion is the more information you give, the better, especially if we can input that information into an articulator. I've found it's been something that I've spoken to a bit about with the specialists here. The minute we open something on an articulator, I think we add a variable. So if you take an open byte and it's an accurate open byte and we don't need to open the articulator, I think that gives us the best possible chance to replicate reconstruction that's going to be in the correct position. And one of the conversations I had actually today was, I believe as soon as you open something on an articulator, it's a fixed hinge, there's no muscles involved with that movement. So you're opening up the chance of there being a bit of a variable and potentially adjustments that will be required. But I think if an open byte is taken and you have a protrusive record where you can emulate those eminence angles, then yeah, all of that information can be plugged into the computer. If you reset that initially on that articulator and you know what those numbers are, you literally just type those numbers into the boxes on the virtual articulator once you've set those onto the physical articulator. But you need to actually go through the process of physically setting those onto the articulator first.
All right, great.
Yeah,
so we'll give everybody...
Okay. All right, I missed all that, Amanda. Amanda, I don't think any of us can hear you at the moment.
Sorry about that. Right. Should I turn it up? Yes. Okay, great. Perfect. Did everybody hear me thank our sponsors? Okay, that's all right. So the sponsors for tonight are Cohesive Finance, and we just really want to thank the sponsors for supporting these webinars, because if not, they would not be free. So if they are providing something that you are interested in, please consider giving them some love. For ADA members, the ADA has a national library, and I personally use this service quite a lot. You can email Penny at the ADA library, and she can send you any articles that you would like if you give her the title. And my favorite bit is that you can actually send her, say you're interested in digital splits, you can send her a topic and she'll send you as many articles as she can find. The ADA library, I'm not sure if I meant to say it, but I'll say this, the ADA National Library is not very well utilized. It's a service that may not last for a lot longer unless we all collectively support it. So please show them some love if you are an ADA member. That is the phone number there, and email address, library@ada.org.au. And just a reminder about the masterclass in oral medicine by Professor Camille Farrar, Clinical Associate Professor Ramesh Balasubramaniam, Professor Michael McCullough. They will be at the end of this week in Melbourne, followed by Adelaide and then Brisbane. If you are interested in oral medicine, this is a fantastic one-day course to attend. There is a lot of content in there. I did attend the one-day Perth course, and it's not targeted at registrars or trainees only. It's for everybody. It's really a fantastic course. All right, let's just see if there's any more questions. Okay, great, not a problem. So if you have any queries, or if you want to discuss anything further with Brett, please feel free to contact him. I think he's given his contact details there on the Digident slide, which I'll go back to. And once again, thank you everyone for attending the webinar tonight, and we hope that you found it interesting. Thank you. See you.
Thanks everyone, and thanks to you, Amanda, for taking your time tonight as well.
Just a couple more comments coming through. Oh, yes. Thank you, Richard. And thank you, Meredith, as well.
Thanks, Richard. Yeah, thank you.
Later.
Thanks, Lee.
Okay. All right. Good night. See you, Brett.
All right, thanks very much. See you later.